All right. Today's topic, solving equations that involve sine or cosine. And if you're working out of another book or something like that, uh, this may be called solving trigonometric equations. Okay? But I thought rather than try to explain what the whole type of problem could be, I just show you a real easy example. I don't think they get any simpler than this one. So let's talk about this one, and this one will establish the basic thought process and the considerations for this sort of problem. Okay? So it says cosine of what angle is equal to negative root 3 over 2. And we're looking for the answer or the answers, if there's more than one, that's between 0 and 2 pi, or 0 and 360 degrees if you want to think about it like that. So what should the angle be? Okay. Now, how about this? We can sometimes make use of our calculator to do this. And as far as what cosine is versus inverse cosine, the way things work when we do this is that you take cosine of an angle and you get a number. Like, you take cosine of some angle and you get that number, right? That's how this thing's built, and that's how we use cosine. The flip side of that, like, suppose you know the number and you want the angle, what do you do then? Well, you can take cosine inverse of the number and get the angle. Okay, so that's, obviously worth knowing. Now, let's say that I'm going to use my calculator, not because I don't know, just because I want you to see it, and say, okay, let's start this thing like this. Let's say x, the angle should be cosine inverse of negative root 3 over 2. Okay? Because, that will tell us the angle. That's what this says over here. So I want to show you what my calculator says if I do that. Okay, so cosine inverse, there we have it. And that number was negative root 3 over 2. Oops. And, all right, let's see what it tells us. It says 150 degrees. Okay, my calculator's in degrees right now. So let's say, well, x is going to be 150 degrees. Now, the question from here is that the only answer? Okay. The way that we use inverse cosine is it will only return an angle between 0 and pi, or 0 and 180 degrees. It doesn't give you every angle that exists. It gives you that number. It just gives you one answer in a specified range. So could there be more answers? All right. Now, so let's put this on hold, because I think to tell you about that, I need to talk a little bit about the unit circle and something called a reference angle. Okay. So I think to go from here, it would help a lot to either just know the unit circle or have access to the unit circle and at least understand what you're looking at when you see it. Or my preference is to just know the proportions of a 30, 60, 90 and a 45, 40, 5, 90 triangle. So these are the proportions that those triangles have. Like, so, every 30, 60, 90 triangle in the world has its shortest side to be across from the shortest angle. So let's say x. All right, x is the shortest side. The longest side is across from the 90-degree angle. It's twice the shortest side. And the middle side across from the middle angle is bigger than the shortest side by a factor of root 3. Okay? And so you can get, sine of 60 is opposite over hypotenuse. That'll reduce to root 3 over 2. And you get all these typical values. All right? So those are the proportions of the 30, 60, 90 triangle. The 45, 45, 90 triangle, these two sides have to be equal because they're across from equal angles. Let's say x, all right? And then this side is the biggest side, and it's bigger than either of these by a factor of root 2, okay? It's this side times root 2. So those are the proportions. In the unit circle is based on this. All right, I'll show you how in a minute. What do I mean by proportions? Well, you know how on that other picture I just said, well, here's the 30, 60, 90 triangle. Let's say the shortest side is x. And I'm just saying, like, this side's double whatever that one is. So, for example, here's two triangles that have exactly the same angles in them, 30, 60, 90. And, you know, here I actually, when I drew this for you, I think everybody who learns pre-calculus should have a protractor and a ruler, because so much of it does come down to being just measurement. So I drew these to scale with my protractor and my ruler. And if I sketch a 30, 60, 90 triangle, and if this side right here is 1/2 inch, which it is, that would make this side double whatever that side is. That would be 1 inch. And that would make this side, you know, whatever this is times root 3. 0.5 times root 3 inches, okay? Here's a much bigger triangle, but it has the same proportions, okay? If this side is 2 inches, which it is, I measured it, that makes this side 4 inches. Those are just the proportions that that triangle has. You double this side to get that side. And then this one is bigger than that one by a factor of root 3. Okay, now I think that's worth knowing. I think that makes pre-calculus a lot easier. Now let's explore then this, like, because I got you to here and I said, well, could there be other answers? Is 150 degrees like the only answer? And my thinking is, there's another angle, and here's why, okay? So say, what's 150 degrees look like? 150 degrees looks roughly like this, okay? So like so, 150 degrees. And you see there's this reference angle tucked in here of 30 degrees, because 150 degrees is 30 degrees shy of 180. So, you know, here's why 150 degrees works as an answer, because, you know, if we could imagine this is one little piece of the unit circle, then cosine of 150 would be the adjacent side over the hypotenuse. Well, what are the proportions of this triangle? Let's say that, like, this was 1, okay? I mean, we could choose any number because we're just worried about the proportions. But if that shortest side is 1, we said this one was 2, that's the longest side. And then we said this one is root 3 bigger than that one. So, well, we'll have to say negative root 3 because we're on the unit circle and that's left. Okay, that's why cosine of 150 degrees is negative root 3 over 2. That's why my calculator gave it to me. But is there another angle that does that? What if you could, like, take this triangle and put it down here in quadrant 3, where cosine is still negative? Yeah, it would still work just as well, wouldn't it? Right? Yeah, so here's this angle where that gap right there, that's still 30 degrees. So, but what is that angle though? You're going to get a 30, 60, 90 triangle. This side's going to be root 3. This side's going to be negative 1 because it's down. And this side's going to be 2. All right, well, cosine of this angle right here, whatever that is, see that angle? That's also going to be negative root 3 over 2. Even though my calculator didn't give it to me, it's going to work. It's going to serve as an answer. Well, so this angle right here, giving me that triangle, that's going to be 180 plus 30, okay? Well, that's 210. So the way it works is our calculator will give us one answer, and then we'll have to, you know, at least the way I do it, I mean, somebody else can show you something different, but you know, I'll just take that and say, well, like, where else could I put this triangle to make it give me that answer, negative root 3 over 2? Now, you might say, why not take this 30, 60, 90 triangle, which is what 150 degrees is based off of, which is what our calculator gave us. Why not put it over here? And my answer is, okay, you could do that, but cosine's not negative in quadrant 4. Okay, so, you know, I wanted the proportions to give me root 3 over 2, but I knew I had to put it over where cosine would be negative, because after all, that number is negative. All right. So that's a little bit of a crash course in doing this, but I'm making use of what you would have learned earlier in pre-calculus called reference angles. I'm not really calling it that, but that's the way I'm thinking about it. Okay. All right. Let's try another one. What about this one? So to solve this one, I need to get it down to like, I showed you this last one because this is where we end up when we solve anything more complicated. It's going to say cosine of what angle equals this number, and we'll use our calculator to get us started, and then we'll think a little bit about the unit circle and reference angles to get the other answers. Okay. All right, so I want to get this one down to like this point. Cosine of some angle is equal to some number. And then I'll use my calculator. But, that's where I want to be. To get from here to there is going to take a little bit of algebra. So let's think about it like that. Like I'll add 1 to both sides. And I'll say 2 cosine squared is equal to 1. And then I'll divide by 2. And I'll get cosine squared is equal to a half. Okay? And then I'm kind of getting down to that point, right? There's a principle of equation solving where it's like we had, say, number a squared equals 16. How do you solve regarding that there's a square right there? Just a matter of fact that the answer is plus or minus root of 16. So the answer is either 4 or negative 4. It's easy to verify that both of those work, isn't it? What is 4 times 4? It's 16. What is negative 4 times negative 4? It's also 16. So when we solve for a square, we'll take both plus and minus root of the number on the other side. So I will get cosine of x is equal to 1 over root 2. So that's positive, right? The positive root. And I'll get this other one. Negative 1 over root 2. Okay? All right. Now, if I, again, use my calculator, and I do this, let's say, what is cosine inverse 1 over root 2? Like, just to get us started. I think most people are just going to use their calculator to do as much as they can. So it's 45 degrees. Okay? So it gives me this initial angle of 45 degrees. And it is true. Cosine of 45 is 1 over root 2. There's another one that works by the same thinking that I showed you in that first question. Okay? Imagine if you put 45-degree triangle over in some other quadrant where cosine was still positive. All right, that's what the other answer is going to be. And then what about this one? Okay, so say we did cosine inverse negative 1 over root 2. All right, that's how we would solve for the x there, at least with the inverse function in the calculator. And it gives me 135 degrees, okay? So x is equal to 135 degrees. Are there more? Yeah, there's, what's 135 degrees based on? Like when you think or imagine what 135 degrees is, it looks like this. 135. It is 45 degrees shy of 180. Okay? All right. And so what 135 degrees is based on is the 45, 45, 90 triangle. Where like say that's negative 1 and that's 1 and that's root 2. What did we say the proportions were of a 45, 45, 90 triangle? These two sides would be equal, and that one's bigger by a factor of root 2. So if this was 1 and that was 1, if that's just how big I drew it, this side is root 2, which is about 1.4. So yeah, I see it now. Cosine of 135 is negative 1 over root 2, right? Here's 135. Cosine is adjacent over hypotenuse. That's negative 1 over root 2. Where else would this happen? What if you put 45 degrees down here? Wouldn't you get the same triangle with the same proportions? You get -1 over 2. So that'd be down, that'd be -1. That's left, that's -1. What's this angle that's 45 degrees past 180? That's 225. Okay, so what's the other one that accompanies this? Cosine of 45 is 1 over root 2. So 45 degrees is here. It's in quadrant 1. Where else could you put this 45-degree triangle that cosine is positive? Where is cosine positive? Cosine is x over r. If you think about it by the unit circle, it's the adjacent side, which is on the x-axis, over the hypotenuse, if you think about it like that. Well, if you put this down in quadrant 4, okay? What's this angle in quadrant 4? It goes all the way around like this. Where that gap right there is 45 degrees. That would be 315. 315. 45 degrees short of 360 degrees. Okay? So 45 degrees and 315. Now, as I'm doing this, I'm giving everything in terms of degrees because that's a little bit easier to think about. But, you know, if the question does insist on the answer in radians, then you can do all your thinking in degrees, and then you can convert to radians when you give your final answer. So this one's got 4 solutions: 45 degrees, 315 degrees, 135 degrees, and 225 degrees. Okay? Convert to radians if you need to present your answer that way. All right, now, what does this have in common with the first one? Well, I sort of chased the problem down to this, and my calculator gives me one answer, but I have to envision an angle in another quadrant that works the same way. 150 and 210 both create the same 30, 60, 90 triangle, same proportions. That's why they both work, okay? And cosine is negative in both of those quadrants. That's exactly how I thought about this. I got some initial answer from the calculator, then I repositioned the angle in a quadrant which would also work, got my other answer. Okay, let's try one more. So I guess I did like an easy problem and then one of, say, medium difficulty, and then I think this one is a lot harder, okay? Now, my goal is to chase this down to where it says something like cosine of an angle equals a number, and then use my calculator and then solve it, okay? So we know that much. You know, this one, it's got sine in it, it's got cosine. You know, this angle x is not the same as that one, which is 2x. You know, this angle is twice as big as that. So, you know, normally when we have something that doesn't fit what we're expecting and it has trig functions in it, we use identities to get it where we want it to be, okay? And it takes some practice to work with identities because there are lots of identities and you might have trouble remembering them. Or even if you had a formula sheet to look them up on, it's kind of a little game to figure out which ones are going to work to get what you want. It's not a very fun game, but you know what I mean. So, all right. What I want here is the double angle identity. Sine of 2x is 2 sine x cosine x. Okay? And I'm going to go ahead and leave this alone. All right. Now, if I could get sine squares and cosine squares, I could use the Pythagorean identity, which is that sine squared plus cosine squared is 1. If I could get everything to be squared somehow, then I can use this identity to turn cosines into sines. Cosine squared is 1 minus sine squared, or sine into cosine. And I'm not really going to get anywhere with all of it mixed up, with sine here and cosine here and so on. Why is that? Well, it does take some experience to know that. So I'm showing you this problem so that, like, if you saw one similar to it, you'd say, oh, I remember what I saw Jeff do to solve something like this, so I'll do that. So here's what you want. If you want to, you can take an equation and you can square both sides. If I do that, I'll introduce sine squared and cosine squared, and then I'll be able to use that to rearrange things the way I want. All right. Now, if me doing this caught you way by surprise, but I'm afraid that's just how it is. But like I said, that's, you learn through exposure. You see how people solve problems, and then you solve problems that are similar the same way. So I square the left. 4 sine squared x cosine squared x. Okay. Over here, 4, and then cosine 4th power x. Now, it will be best to solve this if everything is either in terms of sine or either in terms of cosine. All right, that's my approach on this thing. So what I'll do is I'll turn sine squared into cosine squared. It'll be cosine like the rest of them. Sine squared equals 1 minus cosine squared. So let's see, 4, 1 minus cosine squared, cosine squared, 4 cosine to the 4th part. Now everything is in terms of cosine. Suppose I multiply all this together. Say I distribute 4 and cosine squared. Distribute in there. I'll get 4 cosine squared. Distribute it on the 1 minus 4. What is cosine squared times cosine squared? Cosine to the 4th power. And then over here I'll get 4 cosine to the 4th power. So let's move things around a little bit. Okay. How about we move everything over to this side and collect like terms? We get 0. I add this 4 cosine 4th power to both sides. I'll get 8 cosine 4th power. Okay. And then I'll get minus 4 cosine squared. Now, this is the sort of thing that I can solve by factoring. Okay, now again, there's a fair amount of algebra to doing this. So we got to know how to solve equations just in terms of x and y and factoring and quadratic formulas and things you learn in algebra class. I need to do something like that here. Okay, let me show you why. Suppose I can factor out a 4 and a cosine squared. Okay, so I'm going to say 4 cosine squared is 2 cosine squared x minus 1. Now, there's this principle of algebra. It says if one thing A times another thing B equals 0, then that means that either A is 0 or B is 0. I hope that that's not too far out there. What does that say? It says the only way to multiply two things and get 0 is to multiply by 0. One of the things has to be 0. That's what's going on here. I got this times that. So either this first thing is 0 or the second thing, the second factor, is 0. So I'll solve each of these. Suppose I divide both sides by 4. What's 0 divided by 4? Cosine squared x is 0. 0 divided by 4 is 0. Remember we did a problem just a minute ago where I talked about how do you solve for a square. You would take plus or minus root of the other side. So what is the square root of 0? Well, it's 0. There's no negative 0 or positive 0. So we get this one down there. So cosine of what angle is equal to 0? If we use our calculator, it will tell us that it's 90 degrees. Okay, cosine of 90 degrees is 0. All right, so we'll get that one just right away. Is there another angle that has cosine to be 0? Think about it like this. Why is cosine of 90 degrees 0? So there's 90 degrees, looks like that, right? I don't see a triangle. You know, I would say cosine is adjacent over hypotenuse, or opposite, or sorry, x over r. There's no triangle. So I guess like the fact that we're going up there, the x is 0. That's why cosine of 90 is 0. Is there another angle that's like that, where the x component, if you know cosine is the x side over the r side, is there another angle on here where cosine, or where the x component is 0? What about this angle down here? What's that angle? 270 degrees. Okay, so 90 and 270. Those are our answers to this one. If you had used your calculator with inverse cosine, it would have just told you 90, but you'd have to realize 270 degrees works also. What about this one? Let's see if we can solve this one. Wait, we did that one, right? So I knew I had a method to my video. Yeah, we definitely did that one. Okay, right? So there are the answers that we got. Okay, 45, 315, 135, 220. So we already did that. I don't have to do it again. So let's say like from this one, we'll get these additional answers. 45 degrees, 315 degrees, 135 degrees, and 225 degrees. Okay, already done earlier in the video. So it looks like I get 1, 2, 3, 4, 5, 6 answers. Now, do we really get 6 answers? Okay. Well, the more math you learn, obviously the more there is to remember as you're doing new things. So there is, see this step in the red pen when I squared both sides of that equation? That does introduce a little bit of a problem. So you can do that, but you have to take something else into consideration. So let me try to get you to understand why. So see this equation? It says number A equals 4. The solution is obviously 4. I mean, it doesn't get any more obvious than that. What if you plug 4 in for A? Is it true? 4 equals 4. It's true. Now suppose I square both sides. So I square the left, I get A squared. I square the right, I get 16. You can do that. But all of a sudden, there's more answers. Like to that, the answers are 4 and negative 4. You know, what's 4 times 4? It's 16. What's negative 4 times negative 4? It's also 16. So I took an equation with one answer, I square both sides, and now it has 2 answers. So, all right, what's my point? If you square both sides of an equation, you will introduce solutions that may not work in the original. So you always check. Your goal is to solve the original equation. If you get your answers out of this one like that's down there, those answers are supposed to work up here. If you square both sides, that may not happen. So you absolutely must check. Okay? All right. So even if I did everything right, I have to check and make sure. Okay. So let's see. Like now we'd have to check all of them, and one at a time, make sure that they work. So let me give you an example of one. Like how about this? I'll just show you one of them that doesn't work. Okay. So let's do 272 or 270 degrees. I'm sorry, let's do 135. Okay, that's one of the ones that doesn't work. But say like I've got to check these one at a time. So does 135 degrees work in this original equation? If you plug it in, doesn't make it true. That's what makes it an answer, right? So sine of 2 times 135 degrees equals 2 cosine 135 degrees squared. All right, and I'm going to put a question mark as if I'm not sure that all of these work. That's the nature of squaring both sides of the equation. So 2 times 135, that turns out to be 270. So I'll get sine of 270. And then cosine of 135, that's going to be negative 1 over root 2. Again, you use the calculator or your unit circle, or if, like earlier, you learned the proportions of the 45, 45, 90 triangle. So is this true? Right? All right, what's sine 270? It's negative 1. What is negative 1 over root 2 squared? That's going to be 1/2. And is negative 1 equal to 2 times a half? 2 times half is 1. No, it doesn't work. So that's what I was saying. That if I square both sides, I might get all of these justifiably, but that doesn't mean they work in the original problem, and that's the one I'm trying to solve. So let's say this. Suppose that you check each one of these. These are the ones that you're going to get to work. Okay, so here's my final answer. 45 degrees will work. Okay, 225 will work. 90 degrees will work. And 270 degrees will work. 135, for example, won't. But you would check them to know. All right? So there's my final answer. If, again, you need to give your final answer in terms of radians, then you can convert at this point. But again, I mean, why not? I mean, degrees are a little bit more natural to think about. Why not do all your thinking in degrees and put your calculator in degrees? And then once you answer it, if you need to convert to radians, you can do that. All right, so we started with an easy problem, worked up to a more complicated one. They probably don't get much more complicated than this in the class you're taking. Can't promise that, but it's probably true. But what does it involve? Got to know some identities. Got to use the right identity at the right time. Need to know some algebra for sure. Need to know things from algebra like squaring both sides of the equation can introduce false solutions, and so you have to check through them. But, there it is. I thought this last one gave a nice summary for this topic.